Okay, we've got a question about a normal distribution. We know the mean. We're also given this information that I think we'll come to later on. Okay, the first thing we've got to do is write down the median weight. Now this is just testing really your knowledge of what a normal distribution looks like, indeed the fact that it's symmetrical. Okay, so we know the mean value is 200 grams, and because it's symmetrical, write down of course is code for the fact there's no work to do. You need to know that means and medians are coincide, or in the same place for a symmetrical distribution. So that's an easy mark to get you started, but even if you didn't get it, B is a re-entry point. Okay, so now we've got the classic normal distribution problem. We've got to find the standard deviation. Okay, so we're finding something other than a probability, which means we must have been given a probability. Okay, so the probability, anything that's expressed as a percentage may be a probability. 60% of bags weigh between 190 and 210 grams. So that is a probability. If we know the proportion of bags in between those weights, that's a probability that a bag is between them. So at this point in any normal distribution question, you need a decent picture. So on our normal distribution, they told us the mean was 200. Okay, and we're interested in the proportion in between 190 and 210. Okay, so that is this part here. Okay, and we know the probability of being in there is 60%, which is 0.6. So that's a great diagram for transferring the information that we were given in the question. So now we need to find a diagram we can use in conjunction with the tables. So what we really need to do, we've got 0.6 here. The good thing is it's symmetrical. These are same distance either side, 200. So therefore the bit that isn't here, the 0.4 that's left over, taking this away from 1, must be shared equally. So this must be 0.2 and this must be 0.2. So now we can just draw a simpler diagram that shows, okay, that we have 210 here, we have the mean at 200, okay, and this bit here, this is 0.2, but this bit here is 0.8. But whichever of these we end up using, it's important to realize that this is a value of a probability of P. Okay, now if we now go to your formula booklet to see what you've got, this is a table you've got on page 18, which has Z values and the probabilities. This just means probability that goes with the Z value. Okay, so if we want the probability to be 0.8, we could look for 0.8 here, and we could get close to it. Unfortunately, we need the exact Z value. So this table here works with, I'll show you on paper, works with a Z value here, and then the P value, the probability to the left of that Z, and this is always a positive Z. Unfortunately, if we've got a P value like 0.8 and it isn't appearing in the body of the table, we might have to use the other version of the table. Now the other version of the table works the other way round, just to help you out, and the P value they then show you is the one here, and they give you the Z for that particular p-value. So we need to look up 0.2 in the second version of the table. So here's page 19 of the formula book. So we be careful, we make sure we get the correct p-value. Here we go, 0.2 gives us a z value of 0.8417. So when this area is 0.2, this z value is 0.8417. So that means this position here is a z value of 0.8417. So I've got the values in terms of the number of grams of popcorn, and now I've got the values of the z's, and it's this equivalence here that I use in the standardization formula. Okay, so remember the standardization formula is z is the x value minus the mean divided by the standard deviation sigma. Okay, so in this particular question, sigma was what you're trying to find. Okay, z, we've got a value for z, so that goes in here. Okay, the x value for that z is the number of grams of popcorn, which is a 210, and mu, which is the mean we were given in the question, was 200. So we substitute these three numbers in and find sigma, and that's how you do this part of the question. So we've dealt with part B, finding the standard deviation, and now there's a follow-up. We now have to find the probability that a customer will complain, which happens when the bag weighs less than 180 grams. So this is now a forwards question. We're finding a probability, so it's the opposite direction. In the previous task, I started with a probability of 0.6. I used the tables to get my Z value, and I used the standardization formula last, okay, to find the missing thing, which was sigma. Okay, but for the one that I'm now doing, again, I need a diagram. Okay, this was the probability the customer complained because the bag weighed less than 180. So we've still got a mean of 200, which is a Z value of 0. And 180 obviously lives on this side. Okay, and the probability a customer complains is this area here because the bag weighs even less than 180. So I want to find this value of P, and in order to do that I need to use the table, but I'm going to use the table by looking up a Z to find the value of P. So where does Z come from? Z comes from the standardization formula. Z equals x minus mu, okay, over sigma. Well, sigma was found in the previous part of the question, so you use your answer to part B for sigma. I've got an x value, okay, 180, and I've got a mu value. So these values here are going to be substituted into the formula as is sigma, and then you can calculate a value for Z. Okay, now you can see from the diagram that Z will be a negative Z, but in the table we're going to be using the table back on page 18, but you can see that Z starts from 0, and we've only got positive Z's in this table. And what that means is that we have to take our diagram and we have to turn the diagram the other way round. So in order to use the tables, my Z has got to be the negative of this Z. So I'm flipping over, and that's a probability I want to find. So this Z value here, I'm just going to put Z, but it's this negative Z value made positive will be whatever you look up here, and what the table will give you is this value here for P, because that's what the table on page 18 does. It gives the probability to the left of Z. So you're going to use the table from page 18, this one here. You're going to look up whatever Z value you got in here, and you're going to get a probability. Notice all these probabilities are greater than a half. So you look up your Z value, you get a probability greater than a half, which will be this unshaded area here, and then you have to take that away from 1 to get this area, this probability, which was the same as this, which was the probability of being less than 180 grams. I hope that has helped.